Hey everybody, it's me, it's Rob. We are back for another edition of Serverless Office Hours. Today's topic is unit testing your Lambda functions in Go. If you see up here, we got a packed agenda today. So I'm gonna try to get through as much of this as I can. I've pre-staged some of the code, but I'm also gonna actually write it as we go so that you can see the experience. If you're joining us from the AWS channel that Eric Johnson just did, thanks so much for joining. We'll be using the same AWS SAM CLI that he was using. I'll go ahead and drop a link to that into the chat room so that if you don't have it, you can get it installed if you want to follow along or use it later. There's a link for that. So we'll create a function in Go, and then we'll do a little bit of a deep dive into the anatomy of a Lambda function in Go, how they work, what they look like from a type signature perspective. And then we do that so that we can understand the need for receiver functions and how they interact with dependency injection, or rather enable dependency injection to support our unit tests. Then we'll write a quick unit test, work through a couple aspects of it, and then move some initialization bits around in our code from the main function to the handler, so that we can see the performance considerations and see which one is better off for us and what might have you choose one over the other. Then we'll wrap with Q&A, and I'll just go ahead and give away the special announcement now. Thanks to the AWS channel for hosting right now, but I will also be on that channel for next week's office hours with a very special guest, Richard Boyd from AWS Developer Tools. You're not going to want to miss that one. It's going to be an exciting show. So thank you all for joining us. Thanks to the people who contacted us after last week's show. I don't want to say your names on air because of privacy concerns, but if you out yourselves in the chat, I will. It really means a lot when we get that feedback. So please just, anytime you can, ask your questions. We're here to answer them, all right? Let's move on. So the first thing we're gonna do, I posted that link to SAM CLI, and it's just it's a framework for creating our applications on AWS Lambda. In our case, we're gonna create one. We see the SAM init here, and you can do runtime or -r. We'll do runtime go 1.x. All of my examples today are gonna be in Go. It wouldn't make much sense to do an episode called unit testing your Lambda functions in Go and use a different language. It's my preferred language of choice. There's a lot of really good reasons to use it for writing your Lambda functions. It's insanely fast, so you can sort of accomplish the same work in less time, which is less money when you're doing Lambdas. It's also just, it's built for the cloud, so huge fan. This created unit testing folder for us. Let's open this up in Visual Studio Code, and let's see what we got going on here. Oh, you know what helps? A couple things. One, when I open the current directory, and two, when I open it on the right display. So let's check this out. First things first, I'm gonna get this nice and big for y'all. And then if you don't know about this, we're gonna do some toggle screencast mode so that you can see when I do stuff like bring up the command palette or when I get all pointy clicky. So again, when we talk about the anatomy of a Lambda function, we're gonna start with this example that Sam gives us. This is just like a regular Go program. It's got its main package, your imports, you can define some variables. We'll get rid of all this stuff because we won't need it. The meat of this is right here. Here's your handler function. And if I close this, you can see the full signature. So you see your handler will take in some individual type in object and return some individual type out object and an error. Now that's one signature. There's 7 possible signatures for Lambda functions in Go. I'm gonna drop that link in here for you too. And those are just variations of no argument or type in or error only. If you return a value and only one value, that must be an error. If you return 2 values, that second argument has to be an error. All right, so if let's open that link ourselves and I can do a better job of showing you what we're talking about here. So you can declare your handler function to take and return no arguments, to return only an error, etc., right? There's also a context object that you can pass in. We're not going to be using the context object today. So let's switch back to code. All right. The other thing is we've got our main, right? Like I showed you up top, this is a main.go, it's package main. And just like any Go program, it has to have a main function. And you'll see right here, all it does is start this handler. And then the handler, if you want to review the code, goes in and receives the events, processes the function, right? So we can't modify that signature to pass in things that we want to pass in. We're stuck with those 7 signatures. And that's why dependency injection becomes important. And this is a pretty well-known pattern, right? So dependency injection allows us to provide all of the dependencies to the function when we call it or when we define it. And that way they're not inside. So as an example, if we write a function that writes something to a DynamoDB table, then we need a DynamoDB object. And we can either instantiate that here inside our handler, or we can pass it in. But we know from looking at those signatures that we can't just modify those signatures. The Lambda package will only accept one of those 7 signatures. So what are we going to do? First things first, I'm going to delete this because we're not going to use these. We're going to clean this code up a little bit. We'll delete all of this. You see that Sam has gone ahead and given us events in Lambda here. And I'm going to take out all of this except for the return object, right? Because we're still going to return the same signature. So what we're looking at here is, this is fronted by API Gateway. Call comes in, we get that proxy request object. That's TN from those 7 signature types. And then we do some things and we return that proxy response object. That's T out and an error from those signatures. All right, so what we want is some way to get a DynamoDB object inside of here. Now, we can just instantiate one. And the way you normally do that is, I'm going to try to do this from scratch. Don't worry, I'm not going to waste a lot of your time. Nope, it's not. It's session.new, session.must, session.new. There we go. See? I didn't have to look yet, but don't worry, I will check. And then we can do ddb equals, I'm gonna have to fix that. That's not right. Is it DynamoDB? Session. All right. So I'm gonna go back and check my code to make sure I'm not giving you bad info here. Let's make sure, check myself real quick. Session, session.must, session.new session. Sorry, see, I was giving you bad info. There we go. We'll skip the options. And then DynamoDB.new session. Yeah, there it is. Okay, so there's some errors here because we haven't finished cleaning this out yet, but there's a problem with this, right? If we want to test this function, we don't have any way to invoke it from our test function by mocking something up. We want a way to pass that in. So we need to pull that outside of here, right? And there's a couple ways we can do it. The way I like to do it is to pull it down here into main, and then we'll create a dependencies object. Call it deps. Oops, no spelling, there we go. And we'll pass it this and a table. It'll be a string, right? The table name. So we need to define this dependency object up here. It's a struct. And so let's look at this line first as we do this. We don't want to give it a DynamoDB object because it's not actually going to be the DynamoDB service that's running it. Every service in AWS in the SDK has an interface object as well. And what that is it's an interface that's normally fulfilled by the service itself, but that you can fulfill via a mock to do your own testing. So in this case, we will pass in We wanted a DDB of type DynamoDB iFace .dynamodb API. There we go. And we want a table of type string, right? That'll just contain our table name down here. So I'm going to change this so I can get rid of this unused variable. And since that's just a string, we'll just move all this out, right? All right, so we've got this, it's a valid implementation of that type, right? Our type deps, it needs a DynamoDB interface. All right, the actual DynamoDB satisfies that. It needs a table name, so let's just call this some table. You would get this from an environment parameter or from parameter store or something like that, from your SAM template itself. Right now, I'm just going to hard code this stuff in so that you can see what's happening. And as is my habit, I'll save that. I'm getting feedback that the keyboard hints might look distracting, so I'm going to turn that off. Let me know in the chat window if you want it back on. It should be pretty obvious what I'm doing. Okay, great. So we've made these dependencies, but so what? Like, it doesn't do anything for us. We still don't pass it into the handler. To do that, we need to go back and address the concept of receiver functions in Go, and specifically pointer receivers. And I'm going to paste a link for you in here to the tour of Golang that'll take you straight to pointer receivers. So receiver functions allow a type to gain methods, and what happens there, they can either be value receivers or pointer receivers. And if they're value receivers, it makes a copy of the entire don't say object, but object, and passes it in, but it's static and can't be modified. If you use a pointer receiver, it can accept either a value or the pointer, and you can modify the values of the object. And that matters because one way of doing this that we'll performance test later is to pass in an empty object, check if the object's empty, and then instantiate it. And I'll talk about why you might do that. But so in this case, what we want to do is something like this, right? We want it to be lambda.start d.handler. So to do that, up here we just define d as a pointer to our dependencies and the handler, right? And so I'm gonna again check my code real quick just to make sure I'm not giving you any errors. Yeah, because I always get that little pointer symbol, I always put it in the wrong place. But in this case, it's where it needs to be. So we've got this handler function now that's a value receiver on a struct of type deps, which is dependencies. You can put whatever you want in here. And we build this dependencies object for our real function with an actual DynamoDB object, right? And you don't even need this. You can cut this out down here to make it even more clear that you're passing in a real DynamoDB object, right? So I'm looking over in the chat. I don't see any questions so far. I know I'm moving through this pretty quickly, just trying to respect your time. So I'm gonna keep pushing, all right? That's half of this equation. So we've got our dependencies type. We defined the handler as a value receiver because we're limited in the types that we can pass to it. I'm sorry, not a value receiver, a pointer receiver. And then instead of invoking a raw handler, we're invoking the pointer receiver, right? So our main function is ready to go. What we need to do now is wire up a test for this function. And to do this, this is quite a bit of code. So I'm gonna copy this one and we're gonna walk through it because I've got a mock that I've already generated. And so of course, for any test, you need the testing package. Here's these packages that we need again. We need DynamoDB here because we're defining input and output types. We need the interface because as we talked about, we're gonna have a mocked struct that itself has a value receiver in this case to mock that DynamoDB.putItem call, right? So this is the same signature if you go to look at the DynamoDB API in the SDK. This is the exact same signature as the DynamoDB put item call, but instead we've made this one receive the value receiver. And this is just a convenience structure to return whatever we pass to it. All right. And so this is a pretty basic test here. We just want to see that the happy path works, that we don't get any errors. So we call this, or we instantiate this, and all we're doing is returning an empty put item output object. And so that won't return an error, which is good, which means our mocked call won't return an error. And now we need to construct a dependency object. This, of course, because these are part of the same package, main, we don't need to redefine depths. In fact, it's defined already for us. So if I were to put something like prefix here, right, that doesn't make sense because that's not actually a type, or I'm sorry, a property of that type. So we instantiate a dependency object with our mock instead of DynamoDB. And then we make a function call to the handler. Again, we're injecting the dependencies, but we're injecting the dependencies with the mock. And it's enough for us, the way we've written this, to just pass it an empty request there, all right? And if you remember from the signature, we should get back an API gateway proxy response and an error. We're not concerned with the response, we're just throwing it away. And then we want to check this error here, right? So let me save this. And in our terminal here, should be able to do this from here. Let's see. Go test -v. It's gonna have to go out and get some of the dependencies, but ultimately it's gonna walk through and then we get this verbal, right? We tested that successful request path and it passes. I know this is backwards from test-driven development, but we can force an error there. Just to prove that this test is being called and not the DynamoDB table. Return that. Fake error, right? So we want to get that in there. And now if we run this test again, we get a failure, right? Because that's what we expected. Everything should have been okay and it wasn't. So we see that this is happening down in the test. We can also check in here and we see we don't have any tables in this account. So we haven't deployed anything from SAM. We haven't created a simple table. We haven't done any of this stuff, right? So all of this is running locally as we'd expect. It's exactly what we want to see. So this is let me undo this here. Get us back to where we want to be. So this is a pattern that you can use to unit test your Lambda functions, right? You pass in everything that you would normally call in the cloud, mock it up to return the values that you want to see back, and then you can test the business logic of your function based on those values. Now, one thing to consider here is that we're creating a new session and a new DynamoDB object with that, and it could time out, or the underlying object could disappear. So you may want to move this code from here up into your function itself and instantiate it every time that the function's called. But that could introduce a performance penalty, right? It has to take some non-zero amount of time to create a new session and to create a new DynamoDB object. The question is, are we going to gain more than we lose by doing that? And so the right way to do this is to test it, and we'll write both. Let's see, we've got a comment here from PG Majid. Thanks for your question. I like this design. It's nice and simple for Lambda. Do you think there's value in using a dependency injection framework, or are they heavier than needed for Lambda functions? So I will answer this question in two ways. One, you should do it the way that your language tends to prefer it, or whatever tools you're most comfortable with. It's better to use a heavyweight tool and write tests than to not write tests, right? And then the second answer to that question is, in Go, generally, one of the tenets is it's better to repeat yourself. What is it? It's better to do a little copying than a little copying is better than a little dependency. I'd get there eventually, right? My personal preference, I wouldn't introduce the complexity of a framework, but again, as these things go to scale, or if you have custom test frameworks that are developed inside your company, or that you already have a lot of tests written for, either one of these is fine, right? Because you're not running your tests on production code. So I would say it kind of depends on what you're used to and what is going to enable you to write the most correct tests. That's what I would do. For me, I keep my Lambda functions as simple and straightforward as possible, so I tend to do all this by hand. Thanks for the question, PG McGee. So we've got this. Let's take a look real quick at this structure that was created. And what we want to do now is modify this function. Before we split out that test, we need to actually write this stuff into DynamoDB, because we need to actually create the client, do something with it, and see what kind of performance differences we're looking at, right? So again, to try and keep this short, I'm going to go ahead and copy paste this code. It uses a package from Segment called KSUID that's been getting a lot of traffic on Twitter lately. I'd like to thank everybody who brought that to my attention. What it does is it creates a sort of time-stamped UUID that allows you to sort UUIDs by more or less by time, right? Not necessarily 100% accurate, but definitely look it up. That's let me see if I have a link here for you. I don't, I'm sorry, but if you look for, I know it because we see it in the dependency. Segment IO KSUID. Definitely check that out if you need something to generate UUIDs for your DynamoDB tables. So if you see down here, I pasted all that code, but there's no change here, right? We're still just passing this stuff into some table. And up here, we've still got a really tight handler function, right? Same signature that we had before. We've defined this sample order type that's going to be our ID in our DynamoDB table. We've got the same dependencies that we had before, the KSUID import that we talked about. So we get ourselves a new ID, we create that order. This section right here is just assembling our Go struct into the golang map between a string and object that DynamoDB expects as input. And then once you've done that, you can build your input object for the function, and we make the call, right? So this will either be our mocked dependency, making that call and returning a positive response, or it'll be the real table making that call and putting it in. Now to do this, we need some table. So we need an actual DynamoDB table to write to. And the place we do this is in our SAM template. So SAM is a transform on CloudFormation, and it gives you a lot of serverless shortcuts, right? This eventually becomes real CloudFormation or vanilla CloudFormation, if you will. But it offers some things to help us get done quickly. We can take this environment variable out. We're not going to use it. And we want another resource that we'll call my table. And it's this type simple table. And that serverless in the middle there lets you know that it's a serverless transform, right? This is enough to create a DynamoDB table by itself. It'll go out and it'll generate the name of the table based on the stack. And there you go. But since we've hard-coded our variable name, I'm sorry, our table name, let's hard-code it here as well, right? I think did I copy that? Oh, no, I did not. Okay, I think I called it some table. Let's check. Yeah, some table. And so with just 3 lines here, we've defined a DynamoDB table with on-demand capacity, with only the ID field defined in the schema because it's implicit, and we've given it a name, some table. So again, really quick, really powerful way to get this going. So we're still in this same directory. I'm gonna run my tests again Oh, see, that'll get fixed here in a second. That needs to get the go get, but Sam will take care of that for us when we run SAM build. Oh. All right, let me go back to my working function over here. So properties, you know what? That's why. They're right. You can't just throw a table name there. You have to put it under properties. Yes, typo. So again, that's just analogous to what we have up here with the function, right? Type properties, type properties. All right, so SAM build or SAM validate. And this is a nice convenience, right? So it's using modules, Go modules. I happen to be running Go 114, but as long as you're 111 or up, it'll work. And then it tells us what to do next to get it out there. That SAM deploy guided. We're gonna call this unit testing. I like Ohio. We don't need to confirm our changes before deploy. We need to confirm the creation, and we're going to save this so in the future we can just type SAM deploy. So now this will put all this up there, and it'll give us an endpoint. It's an HTTP GET endpoint. I know that. That's okay. We're not actually going to pass any data to this. Remember, in our order, we faked all that data anyway. So we're just doing this mainly to see what's the setup time for DynamoDB object in a session, and where we should put it for performance. So this walks through, it creates the role for us. It creates, in fact, I know already something that I did not do, which is, so I can show you how to update stuff. Forgot to give our function access to our DynamoDB table. I'm gonna go ahead and do that as soon as this finishes. Nah, why not? Look, all right, I use HTTP. You can use Postman, curl, whatever you're familiar with. This is going to give us a 500 internal server error, right? Which is the right answer because our function is not authorized to write to that DynamoDB table. And so if I take us back here real quick, we see, all right, it created the table named sum table. That's weird. I must have, I'll need to check into that. But we can also, I'm going to blow this up for y'all, all right? I know it's a little small. Blow that one up. Then if we go to our Lambda function here, monitoring and CloudWatch, it's just going to tell us again, it's not authorized to perform DynamoDB.put item, right? Access denied exception. This is not authorized to perform DynamoDB put item. And that's because I forgot to give it those permissions. So if you were with us last week, you might remember we talked about some built-in SAM roles that are another thing that you get from using SAM. One of them is called the DynamoDB CRUD policy. I'm going to paste this in here now. It goes under properties. So we want to be here. This DynamoDB CRUD policy, I'm going to give you a link to these as well. Takes an argument. Well, I'm going to have to get that link to you in a minute. But if you search for AWS Serverless DynamoDB CRUD policy, you'll find all of them. If anybody's in the chat room that could post that, that'd be great too. But it takes an argument named table name. In this case, we just pass it a ref to my table, right? And then, yeah, it created exactly what I told it to. I just told it to create the wrong thing. So here we have some table. Our Lambda function has the ability to write to it. Didn't need to change our code at all. We're still going to run SAM build because what that's doing is packing up the SAM template for the transform. So in practice, what I actually do when I'm developing is I always run SAM build and SAM deploy just to tie those two together. Just a little quick tip for you. And while that's happening, I'm going to go see if I can't find this link for you. while that's updating. All right, here we go. Yeah, AWS SAM policy templates, built-ins. We love built-ins, and that's still continuing anyway because it's got to delete our old table. Right after Julian. Sorry. Thanks, Julian R. Wood. Appreciate you getting that in there. Just got to wait for the delete on that DynamoDB table. So again, in the interest of time, I want to keep moving on this. This will continue to go. We'll come back to it. That's going to work. So what we'll do here is we'll refactor this into two separate endpoints. One that's a hello main and one that's a hello handler. We'll leave the initiation in main and we'll move it to the handler in hello handler. And then we're going to use a tool called artillery to run some performance tests against it. So first things first, we'll just copy this hello world and paste it. And we'll rename that to hello handler. We'll rename this to hello main. In our template, we'll change all this to hello main. Path, hello main. We're going to leave these as gets again for the reasons we discussed earlier. Yes, in real life, this would probably be a post, but we're not testing the handling of the HTTP body. We're testing the setup of the DynamoDB object. So handler. I know I can do these all at once, but I'm actually really bad at Visual Studio Code. So I appreciate you bearing with me. We're going to take these out. And so just so that we have these API endpoints for our artillery test later. Hello main and hello handler. Let's hope I got all this right, all right? Let's give it a once over real quick. They both have access to CRUD. Hello handler, hello handler, hello handler, hello handler. These should all be main, 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 main. Yeah, great. All right. So we can close these. And what we need to open is the hello handler. And it's pretty straightforward to move this. What we'll do in this case is just make this D be an empty object, empty struct. And we're gonna pull this up to an if statement in the handler, right? So this way, if our Lambda times out, or if we lose the connection to DynamoDB and wind up calling a different shard or whatever, it doesn't have to do that. So the first thing we want to check is if, sorry, that's my JavaScript coming back in. If the DynamoDB object is nil, then we need to set up all this stuff, right? Otherwise, if we're thinking about it, how would it not be nil? That's if we're running a test, right? We would have already passed in the object from our test and we wouldn't need to instantiate it. But so at this point, either it isn't nil and we can go forward, or it is nil and we set it up and we can go forward anyway. So now we can go back here. It's updated that stack. Before we run that test, we can hit this one time and it gives us null. That's actually the response we wanted because there were no old attributes to be changed. So if we go back to our DynamoDB table, now we've got the proper name and we've got one item in it, right? That just went in there by us. So I'm gonna go ahead and delete this for no good reason other than I like housekeeping. And now we're gonna run SAM build and SAM deploy. Uh-oh. Yeah, that's me. Hello world. Main.go 36.3. I know on one of these I did something weird. Line 36. The deps. So it must be hello main. Line 36. Oh, no, I know what I did. Okay, fun. It's never used because it actually falls out of scope here. If d.ddb is nil. So again, because this is a value receiver, we can modify the items. We're going to do this way. Right, because D already exists independent of us. So D comes in here, is declared. I had created another scope, a D inside that scope, and that's why it was failing. So, hooray, live coding. All right, but thankfully it worked this time. When this finishes the deployment, it's gonna spit out 2 outputs. While it does that, I'm gonna go ahead and create the load file for Apache. And what I'm gonna do here is I have one already staged. I might as well just copy it here. There's no need to go through that. All right, so while that's running, we can look at this file real quick. If you haven't used artillery before, I'll go ahead and drop a link in there. Super powerful tool. Basically just hammers whatever you tell it to hammer at whatever rate you tell it to hammer it. And then there's not much more to it than that. So I'm gonna need to replace this. This is an old one. And then we'll have this, we'll actually get from hello main first. I'm not gonna run these together because it'll aggregate the statistics, right? So I'm just gonna do the basic, run these one at a time. All right, and then we got our endpoint here. It's actually /prod/hello main. Replace that endpoint. Looks like I probably should have deleted the word replace first, huh? Big fail. And now it's as easy as artillery run load.yaml. Now this is only going to take 30 seconds. The other one will only take 30 seconds. You're going to want to do a more scientific approach to this, right? What's happening in the background, we can go and check the logs and we'll see that we get several cold starts and Lambda launches new versions of the functions. There's a lot going on, right? So there's a lot behind the scenes here that can cause this to vary. Probably what you would want to do is start with something like provision concurrency in your AWS Lambda function so that they're all warmed up and starting from the same place. Run multiple sets over a longer period of time. But for this is just sort of off the cuff with our main. We've got a P95 of 315. We wanted to see it less than 400, so that's pretty good. So our 95th percentile is 315. I'm gonna copy these and save them there. So this is hello main. And then all we have to do here is modify this to hello handler. And logically, if you think through this, what we'd expect to see is a slower aggregate time because each time inside the event loop, it has to reinitialize that section. Now, how that actually happens is going to be interesting because it's kind of part of the runtime. And if that runtime already has one of those objects instantiated, it's not going to be nil because we modified it. So who knows which way this is going to go? Let's run it and see. And again, this will only take 30 seconds. And then that'll pretty much wrap us up for today with what I wanted to talk about. So while that runs, while we wait for our results, today we went over how to create a SAM app using SAM init for Go. We discussed the anatomy of a Lambda function in Go, and I gave you some links for the 7 valid type signatures for Lambda functions. We talked about receiver functions, specifically pointer receiver functions and dependency injection. And we wrote a unit test, and now we're wrapping up by looking at the performance considerations of moving that initialization out of main and into the handler. So if we copy that and compare this is hello handler, and we compare this side by side with, where's hello main? Let me close this real quick. All right, so if we look at these side by side, slightly slower minimum, faster maximum, which is an interesting result. The median's very close. P95 is very close. 99th percentile is almost a dead heat, right? So you can see that there's very little actual performance implication from moving that initialization out of your main function and into your handler function, which I think is kind of an argument for moving it up into your handler function. If it's more or less equivalent from a performance perspective, then by doing it in your handler every time, you're guaranteed that if something underneath changes that's outside of your control, you still get that connection and that session reopened for you. So based just on this little bit of testing, that's how I would write my my Lambda functions. And it's actually how I write my Lambda functions from time to time. We got PG McGee here with another question. I know Lambda cold start times have improved recently. What's the current average cold start time for Go? Fast. I can't give you the actual numbers off the top of my head for 2 reasons. One, because I don't know them. That's the most important one. What I do know is comparative numbers, and Go is the fastest runtime that we see for cold starts. We see surprisingly fast cold starts with Python as well. But we've also done a lot across the board to reduce cold starts, whether it's from enhanced VPC networking that was released for your Lambdas that run in a VPC, whether it's provision concurrency. There's a lot that we've done to reduce the implication of that. So if you haven't checked into provision concurrency today, I definitely would. If you know your usage patterns and they're not super spiky, then right around 60% utilization, you actually start paying less money for having provision concurrency. So not only is it faster with fewer cold starts, but it's cheaper if you have that sort of model of usage. So thanks for that question, PG McGee. That's it. I know I've taken 45 minutes today. I really appreciate everybody coming out and watching this. Again, this time, same time next week on Thursday, I'm going to be on the AWS main channel with AWS Developer Tools, Developer Advocate Richard Boyd. You're definitely going to want to see that one. It's going to be an exciting episode where we'll walk through again hands-on with some tools. Thanks again to everybody who joined today. Thank you for people who have sent me questions in Twitter via direct message. We love hearing from you. So whether it's a feature request or just a way to get more understanding, please reach out to us at any time. Again, on Twitter, I'm RTS_Rob, and my DMs are open. So there's let's see, Julian Wood added a little bit of context to that answer as well. Depends on what you run in your function. Cold starts have 2 parts, AWS and your code. Also remember, cold starts only affect a very small percentage of your function starts. That's true, and especially depends on the pattern of your function. If you have very short running functions, which Go functions tend to be the fastest running ones that we see, then you don't need as many running concurrently to handle the same load of execution, right? Because the worker releases one invocation and is ready to accept another invocation more quickly. So if it ran for 100 milliseconds, then you could turn over 10 for each instance every second, compared to something that's running for 500 milliseconds, which could only turn over 2. So you would see 5 times fewer cold starts at least, right? And then once those are warm, they stay there warm, running your functions for a little bit of time until they come back down. And that's without provision concurrency. With provision concurrency, you're defining a floor of warm functions that'll always be there for you. Any other questions from anybody? All right, I'm going to wrap it up here. Thanks everybody so much again. We will be back next week on the AWS channel. That is, we'll put a link in here for you just in case you can't find it, but it's not hard to find. It looks just like that. Twitch.tv/AWS. Thanks very much, everybody. Have a good one.